Welcome to the first in a series of calculating axle weight webinars that NTA and TruckScience are jointly running. We're just going to pop into through the slideshow first. We'll go through some documentation then that we need in order to find the information we need to calculate axle weights, and we'll run through a couple of quick scenarios using the TruckScience tool. Before we can calculate axle weights, we need to gather weights, dimensions, and centre of gravity information for the truck, body, and equipment. This webinar is going to cover the information you need and where to find it. We welcome NTA members in US and Canada today. NTA partnered with TruckScience last year to offer association members a next-level solution to NTA's own free weight calculator. The TruckScience Axle Weight Calculator provides a higher level of functionality and support. In the interest of time today, we're going to focus on horizontal or front-to-back weight distribution only. In real life, of course, you'll also need to consider lateral and vertical distribution. These will be covered in detail in later webinars. To use the simple formula to calculate weight distribution across front and rear axles, you need to know the weight of each component, which in this formula is represented by W, the distance between the front and rear axles or wheelbase, represented by WB, and where the component's weight is centred in relation to the front axle, which is signified here by CG, or centre of gravity from the front axle. So in effect, its position expressed as a fraction of the wheelbase multiplied by its weight will give you the distribution on the rear axle. Weight minus weight on the rear is equal to weight on the front. The purpose of today's webinar is just to show you where we can find all of the information to plug into this formula, and to demonstrate using our axle weight calculator how the information allows us to calculate axle weights and payload. When we've calculated axle weights, we can compare the actual weights with the capacity of the axle to calculate how much payload we can add. So every figure we reference from here on will be used to calculate either axle weights or payload. We're going to build a Ford F550 with a knapheide service body, a lift-moor crane, and unbranded sample outriggers from the perspective of an upfitter. Following that, we'll build a Volvo 6x4 VHD 300 with Crysteel dump body, and that'll be from the perspective of a truck dealer. The information we require can be found from a variety of sources, and this list is by no means exhaustive. The most efficient way to source the information that cannot be found on the internet is to leverage your close relationships with manufacturers. So we will today be looking at a sample of bodybuilder manuals, dealer proposal document, the OEM websites. When it comes to the outriggers, we're going to imagine that we've just taken a tape and scales to get the weights and dimensions ourselves. We sometimes need to resort to scaling drawings off these documents if dimensions are not provided. Okay, the first document is the Ford Bodybuilder's Layout Book. On this page 45 of that layout book, we'll find the GVWR, the wheelbase of 145 in this example, CA of 60, and the gross axle weight rating of 4850, 10, and 10,040 front and rear, and the base curb weight, or the unladen vehicle weight. So we get all of that from that first page, that page 45. Next up is page 57, where we'll get some of the horizontal dimensions. You'll see here highlighted in yellow, we've got the wheelbase, front overhang, and the rear overhang, as well as the CA of 60. The front axle to back of cab, or AC dimension, is not specified here, but we can derive it by taking the CA from the wheelbase to get 85.3, and you will see that dimension later as we go through the examples. Page 64 gives us vertical dimensions, including the frame height, those base curb. I know the text is very small here, but we've got frame height, base curb frame heights. We've also got a tyre code from which we can derive the width of the tyre. So the LT245 there is 245 millimeters, which translates to 9.6 inches. You'll see that later. And we've got a tyre radius of 15.9, which is the tyre diameter divided by 2. Again, the tyre radius isn't explicitly stated, but the tyre diameter is. And on the last page that I've highlighted in this document, we can see that there's a 40-gallon fuel tank as standard here, and the fuel tank position is shown on the chassis drawing. While the centre of gravity is not shown, we can estimate it based on other dimensions in the drawing. And it is included in the base curb weight anyway, so it's not that important for the example we're doing today. The other document that we referenced for the Ford is this body application guide. And it gives a definition of the base curb weight as the weight of the vehicle, including a full tank of fuel and all standard equipment. But that's something we'll see later, where we have included a full tank of fuel in the base curb weight. The next place we went was to the NAPIDE website. There are both specifications and literature area on the NAPIDE website. So if we look at the specifications first, we can find the body that we're going to use, which is this 6108D54 with a 60 for a 60-inch CA. We've got the body length 108, body height 40, body width 94, and compartment depth 20. So we get those dimensions from that document, from that web page. If anyone would like these documents, the ones that are freely available, I can send links to them later. You can welcome to just ask for them in the comments after the webinar. There is another document that we referenced then from NAPIDE also. I know my screen is taking a little bit of time to catch up here. This is available in the body literature section of NAPIDE's website. So we can see the model 6108D54 has a weight of 1399 pounds. We also scaled some dimensions from the drawing at the bottom here. Next up, we wanted to find a spec for a lift-moor crane. So again, we did find that on their website, this lift-moor 2010 REE. And as we scroll down this document, find this useful drawing here from which we can derive the length, width, horizontal center of gravity and vertical center of gravity. So while none of those dimensions, well, in fact, the vertical center of gravity is explicitly stated there as 13.750, the rest of them we derived by adding or subtracting some of the other dimensions on the drawing. Lastly, the crane weight of 705 pounds is also specified in this document. So I've saved Ford F350 as a template here earlier, just to speed things up a little bit, but you can also open it as a template. Sorry, I should first actually just show you the various places where you can find vehicles on this screen. So we firstly got a public library of OEM chassis, and these all come with weights, dimensions, and the true-to-life graphics. Then you can use a vehicle template, which is a more flexible item, but with a less pretty graphic. Then there's an area here where I can save my own calculations, or where others have shared them with me, I can open them there too. I can request a vehicle. If you find that you need a vehicle which is not in the library here, you can request it through this facility here on the bottom left. But for this example now, I'm just going to open something I created earlier from my saved calculations, which was this Ford F350. So you'll see that the graphic isn't as pretty as you might expect, but we've got ultimate flexibility here on the dimensions. So as I click on the dimensions, you'll see all of these dimensions that we found in the source documents earlier. Anyone that was paying attention will be able to pick out anything that I haven't, that I would have made a mistake on here, but I have double checked it. So we've got the front overhang, the AC dimension, the CA dimension there of 60. You can toggle in your settings between specifying chassis dimensions as CA or wheelbase. So one of them will always be enabled and the other disabled. And we've got that axle to end dimension there. You can, as you work through this, you can click on when you hover over the vehicle and it goes blue, you can click on the vehicle to open the menu. You can click on the dimensions to open the place in the menu where you can change them, or indeed you can just open the menu from the left-hand side here. We had those length dimensions we found in the documents. We also had these chassis height dimensions, overall height. We're just skipping width and turning ability today, just in the interest of time. We specified the weights and axles, the unladen or the curb weights for the axles, the chassis weight there, as well as the gross axle weight rating. So you may recall that the front axle had a weight rating of 4850. In the tires section here, we specified the tire radius and the tire width. Again, we derived some of those values from tire diameter and also the tire codes. Same applies for the rear axle. In the total tab, then, we can specify the gross vehicle weight rating, which in this case was 14,000. The spare wheel was included. It wasn't explicitly stated in the Ford Bodybuilder guide, but it was stated in that other 2020 application guide. So we can specify that the tools and spare wheel are included in the chassis weight. We specified a 40-gallon fuel tank, which was what we found on the document also, with the horizontal center of gravity that we derived from the other values, and the DCG, which was also scaled off the drawings. We're going with crew weight of 200 pounds per person here. So that's the vehicle. I set up an Epide service body as a template earlier. And again, if I click on the service body here, I can look at that length we had of 108. We got the height of 40. The width was specified also, as well as the weight. So we've specified the weight as 1399 pounds. You can also do a running weight in pounds per feet if that's something, if you're not sure of the exact weight. We can specify the position here manually, or indeed we can just drag the body over and back, and you'll see that the weights are updated on the fly as we go. Now, I had mentioned that as these are template items and we've set them up with the values we found in the documents, we can avoid all of that document work by choosing something from the public library. So if you have requested a vehicle or a body from TruckScience to add to the public library, or indeed if it's already in there, we can just swap this vehicle now, and I'll show you what we call a standard vehicle, the F350 dual rear wheels with the CA of 60. Here we go. Again, I'm going to just take off this body and swap it for the Epide body, which is in our library as well. (6108). It was for 60 CA 6108 D54. This is it. Again, I can just increase the gap slightly for the cab to body clearance. And as we make the changes, our payload is highlighted in the weights distribution table below. So the payload is currently 5636, and we can see that the limiting factor is the total weight allowed of 14,000. Next up, I'm going to import a crane, and that is that lift moor crane that I spoke about. So I'm going to start that lift moor crane. I've actually saved it into my personal library earlier, but if we imagine that it's not there and we need to import a DXF file. So you can see you've got some options here. If you can't find what you need, you can import a DXF file, use a template, or ask us to add it. And in this case, I'm going to import a DXF. So once we've checked it out here in the drawing and made sure that it is the crane we were expecting, just click on next. Then I just want to reposition it at the XY so that we know where to add it on the drawing. So to give it some dimensions, so the length was 100.4 in that spec document we had. The height automatically gets scaled off the drawing, and the width is 19. The weight we found at the bottom of the document was 705 pounds. And the horizontal center of gravity was specified in inches. That value is 71.5. Vertical center of gravity is 13.8. Just ignore lateral for now to save time. So at this point, I need to give the crane a description. Just drag the crane up and back, and you'll see the weights are changing as I go. As is the vertical center of gravity, of course. With the crane, I'm going to need some outriggers. Again, I just added some outriggers earlier as template item just to save some time here. So this weighs 805 pounds. You'll see it's added to the drawing, or the weights table below is 805 pounds, and the weight is distributed over the front and rear axles. And you can see that this is actually taking weight off the front axle there. The 805 pounds is distributed as minus 295 on the front and 1100 on the rear. So we're achieving a payload of 4,037 now, with the rear axle being the limiting factor. We can just demonstrate what would happen if we were to load the payload a little bit further forward in the body. I'll just make this 45%. And we'll achieve a little bit more payload by doing that. So we're up to 4126 now. We've got a number of views down here on the right-hand side, and I'll go into some more of them when we do our next calculation, but I'll just show you the overall centre of gravity view now. In this view, we can see the centre of gravity points for the overall centre of gravity for the complete vehicle, as well as each of the points. So the crew, chassis, payload, body, fuel, crane, etc. And if you want to pin one of those to the drawing, you can do, and you can print it out like that. You can also use this PDF generator up here to print out any of the views that you see on the screen, just to create that nice proposal for your customer to show them that the value you've added by putting this much thought into your offer. You can obviously save that and share it with colleagues with whom you're collaborating in your company as well. This Volvo document is a dealer proposal document, which is printed from the sales tool. Again, going through this document with a fine-tooth comb, you can find that there's a 100-gallon fuel tank as standard on this VHD 64F300 vehicle that we're going to set up, and there is a spare wheel included. So that's more information that we need to know when we're specifying whether a spare wheel is included in the curb weight. Obviously, the more accurate we can make the figures, the more accurate our axle weights will be. Just as we scroll through further, we've got a weight distribution table here with a driver weight and a recommended total body length of 16 foot. So we will be using a Crysteel dump body, a 16-foot body as we go through the demo. We've got a wheelbase dimension here highlighted in yellow of 224. Tare weights for front and rear. And from this table, we can see that the chassis weight does not exclude the driver and fuel weight. We also use this table to derive the horizontal centre of gravity of the fuel tank. So you'll see this 215 pounds, which is the weight on the rear, multiplied by the wheelbase of 224, divided by the total weight of the fuel tank at 684 is 70.4 inches. And that's a dimension we'll see later. So, you know, some of the dimensions aren't always glaringly obvious, but they can be derived from other dimensions. We've got the axle capacity, front axle, suspension and tyres here. Same goes for rear. And again, we've got these codes that tell us about the tyre sizes. So the 425 is in millimeters, interestingly, and the 11 is in inches. So we just need to do a little bit of work on 425 to convert it to inches. And so we've derived our front and rear tyre width from that table as well. Using a bumper to front axle, wheelbase, overhang dimensions, all from this dimensions table. Bumper to back of cab dimension, the BBC there of 113.6. Got our overall height, our driver centre of gravity, and the bogie spread, or the axle spacing there of 54. Lastly, for this vehicle, we've got a chassis weight table with front and rear unladen heights of 45 and 43 or 4 there, as well as the tyre radius dimensions. So these are all fields that you can fill in the app as you go, or indeed if you're working out these calculations manually, you will need them also. Lastly, we're on to our last document now, and this is a Crysteel, the 16-foot body spec document. We've got a body length dimension there of 192. And as we scroll down here, We can find the 16-foot total length, front height, rear height, cross member height. Yeah, and that's it. So we're going to switch over to the app now. For this one, I'm going to start with a vehicle template, just to show you what we can do with the vehicle template for this Volvo 6x4. Again, the graphic is very flexible so that we can change a lot of the dimensions, but doesn't look as close to what you want. Again, you can change all of these items here to change how you specify your dimensions. So that's the template. You get a lot of fields: front overhang, front bumper to back of cab, all of these fields that we saw in the document: height, width, turning ability. There isn't enough time to do that for now, but you've got all these weights and axles. You can specify detailed axle, suspension and tyre capacity for each of your axles, your tyres. You can add further fuel tanks and specify for your crew. I'm just going to go back out to the home screen to choose the one that I've already done. Save us typing all of those in. Okay, so this is looking a bit more like the Volvo that we were expecting. Still a boxy graphic, but we'll improve that just now. So yeah, we've got the 29.1 front overhang that we saw, the and 224 wheelbase, the 118 overall height. We skipped the weight, width and turning ability, but we've got our chassis weight and the axle, suspension and tyre capacity that we saw in the documents. And in fact, I just need to update these. So we had 46,000 axle capacity and suspension capacity, but the tyre capacity is 52,880. This permissible is derived as the lesser of the axle, suspension and tyre capacity and the bridge limit. So despite the fact that our tyre capacity is 52,000 pounds, we are still limited to 34,000 pounds on the rear axle. The document doesn't tell us whether tools are specified or not, so that we've left that as not specified for now. And the spare wheel we did see was included on one of those first pages. The GVWR was 66,000. And that horizontal centre of gravity was derived from the wheelbase and tear split information. Now, so I'll get to put on my dump body now. So this is the Crysteel 16-foot or 192-inch dump body as a template. We've got that 192-inch specified here. We can click on the drawing, click on the dimension, or indeed on the menu on the left-hand side to open that. We've got our heights here, as we got them from the document. You'll remember that there was a cross-member height of 8 inches, and there was a body weight specified of 5502. The position can be changed by overriding this cab to body clearance, or again, just by dragging body over and back. You see the weights are updating as we go. We can just undo that. Again, we're going to just swap out the vehicle. And then we get this true to life drawing, which matches that we saw on that nice dealer proposal document. Swap out the body. Just going to cut that one off. And you'll see we've got this library area where we've got those templates that we've already used, items that have been saved in my own personal library, which are only visible by myself, items in my team library, which I can share with colleagues in my organization, or the items that are in the TruckScience public library. And as the name suggests, these are public to everybody who uses the app. So I have this Crysteel 16-foot body in my personal library here. And you see I've got that nice drawing, which of course you can import yourself as well to get your own bodies into the app. And you've got that very nice drawing now to draw the proposal or generate a PDF. I'll show you quickly what that PDF would look like. So you can specify the name of your customer here. You've got this prepared by, and you can get a sign off on the bottom of this document. You've got a detailed page here with the significant dimensions we're seeing there, the 224 wheelbase, which we specified, and the weight distribution of the vehicle, the fuel tanks, the crew, the body, and in this case, the payload as well. The payload has been, you can print, download, or email that document. It's obviously not something nice to have on file. We can go back to just the payload. We didn't look into that really as yet. So I'm just going here to get my hoist. I've just saved a sample hoist here earlier. And that's just been added on there where you would expect to find it. If you click on that, you've got that template again. For all of the template items, you've got length, height, and width, so you can specify their dimensions and then their weights, including center of gravity.
The alignment of the body at the rear of the chassis is one of those tricky areas, and it's always a good opportunity to engage your bodybuilder for that and make sure that the hinge is in the right position at the back. So you might need to drag that body back slightly and then shorten the rear overhang of the vehicle. So the different requirements for where the payload drops off the end of the body to sometimes to the end of the tire circumference, or sometimes to the center of the driven axles.
So I'm just going to specify a cab to body clearance there of 4. And we'll reduce this axle last to chassis end dimension to, I think, let's try 27. I'll add the hydraulic tank. Again, I've just set up a sample hydraulic tank earlier just to save a little bit of time. You can drag down there. On the drawing itself and in the weight distribution table below, you can see that the app is constantly reevaluating the maximum payload that you can carry. So it's 23,607 at the moment. If, for instance, our customer says that they want a payload of, say, 30,000, we can punch that in there and see what it's going to do to our axle weights. We see now that we're overloaded on both the rear bogie and the total. That is something that we will be covering in the next webinar, adding pusher axles to get more payload capacity on here. And in the third webinar in the series, we'll be delving into payload in more detail as well. So this right now is specified as a simple payload. You can also do detailed payload where you add multiple payload items. So that's something we'll be looking at in future. So if I just toggle back to simple payload and unoverride it, we get that maximum payload figure of 23,607, and everything is back in green.
Maybe I'll just talk a bit about the process of gathering all the information. I mean, Sarika done a great job in explaining all the documents there, the reference documents, and I can see there's a lot of interest in that information. And preparing this webinar, we realized that it's actually hard work collecting all the information. And when talking to people, that's generally the feedback we've had, is where do you get the information? Because you have to talk to your truck dealer, the bodybuilder, any equipment manufacturer, and source all the information relating to dimensions, weights, center of gravity. And some of that information can be quite difficult to find on websites from the various manufacturers. And again, that's when it's important to just personally engage with somebody at the company, and maybe they can talk to the engineers and get you that information. We are there to assist you if you're struggling to find information. So Sarika did show you those features where you can ask us to add items for you. We'll do our best to source information, but we do rely quite heavily on you also assisting us in the process by supplying us with as much documentation as you can give us. All right, that's it, Sarika.
Yeah, so I've just included some summary pages here on the sources of that information. As Martin said, if anyone would like to leave a comment after the webinar that, if you want to get some of these links, I can point you to them. And I have the same just for the Class 8 example. I'm not in a position to share these with you without first seeking permission from the suppliers who gave them to me. We have this series of webinars on the last Thursday of each month for these 3 months. So the next one is on adding pusher axles to optimize bridge, and the third one is on delving deeper into payload optimization and payload specification. So I'd encourage you to sign up for those webinars. If you do want to find the links to register for them, you can go to TruckScience.com, click on the blog, and the first blog post you'll see, if you click in there to the webinar series blog post, you'll find a link to each of the webinars. So even if you want to register for those today, before you forget. Yeah, then in general, if you want to you're more than welcome to take a free trial of the app on our website. There's this start free trial button on the top right. You get in there, you get a free trial, a 7-day trial if you're not an NTA member. If you are an NTA member, you can just punch in the details you use to sign into the NTA website, and that will extend your trial for 30 days. It will also apply a discount of $50 on an annual subscription. So just for your information, an annual subscription is $449, and NTA members get an annual subscription for $399. So I think if there are no more questions, that's pretty much it for me. Thanks very much.
There are just a few comments coming in. Thank you very much. Great, very informative. Thank you for participating and for your questions and feedback. We really value that.
Thank you very much, and we hope to see you on the last Thursday of July.